Just had an update that Ben Hale is on his way.
Everybody's meeting's running long today. If you haven't, everybody, please remember to sign in. Okay, let's kick this off. Standing item, any new faces today? Doesn't look like it, especially since Tyler introduced himself yesterday. Good. Then the next one, I'm guessing this is you, Javier, Behavior Pack.
Yes, it's based on a conversation that we're having in Slack about some of the, questions in behavior in the new feature or set of features with creator and trusted builders in Pack. and we'd like to take some time to talk through it here. Although I believe Emily has a pretty big, voice in this, and I don't see her present. I'm not entirely sure what the best avenue is.
I think maybe it's worth, this is Natalie, by the way, CMB contrib team at VMware. I've been working on this feature. I think it might be worth just taking everyone through the scenarios. I mean, regardless where we end up, it's good to talk about this thing that we are hoping to ship. That makes sense. There's a Miro board linked in the document, which illustrates the various scenarios. I can take everyone through that if that'd be helpful.
Do you mind sharing that just for the video?
Oh, yeah, sure. Here, let me share.
What's the definition of an untrusted build pack?
So we should probably take a step back and just talk about, actually, maybe we should start here. I'll share my screen. Number 2. Everyone can see. So the original RFC is here, number 25. Don't trust builders.
We're looking at your ID, by the way.
Oh, what? My ID?
In
Oh,
Golang. Yeah.
Oh, why did I do that? Oh, hold on a second. Better?
Yes.
Yep. Okay. All right. So the original idea is because we are providing registry credentials to analyze, restore, and export, we want to make sure that the lifecycle that is running those phases is like, out of our life cycle that that we trust. And because of that, we've introduced this concept of a trusted builder, which is discussed here, which is to say, like, I, Pack user, like, trust the builder that I'm running. So it's okay for you to provide my credentials to this builder when running the life cycle. Does that land? I feel like there's a lot of complexity that I'm glossing over, but
I remember talking about this now.
So the idea in this RFC was when I provide a builder that I don't trust. So let's say I find some random builder, out there and I want to play around with it, but I don't trust that builder with my credentials, I can basically rely on Pack to use for these 3 phases specifically, analyze, restore, and export, use a different image. And so what was discussed in the RFC is that we would build an image on the fly with the life cycle from GitHub. And, there wouldn't be really anything else in that image. So we can sort of trust that I'm providing my credentials, but it's okay. It's the official, Buildpacks supported lifecycle that's using that information. The actual implementation that we did in Pack deviated from this ephemeral lifecycle image because we actually came to the conclusion that it would be much more performant if we just publish an image on Docker Hub and pull that one down, which introduced some additional complexity because we're only actually going to publish that image for life cycles that have a fix in them that makes this possible. Specifically, I think Emily might have mentioned this at a previous working group meeting, but previous versions of the lifecycle required the CNB user to be valid in that image, which is no longer possible, right? If we're publishing something on Docker Hub, we have no idea what the CNB user is going to be for when like users out there try to use Pack. So we needed to remove that constraint in the lifecycle. And so as a result, we can only have published lifecycle images for 0.75 and above. Did I lose anyone there?
So I'm trying to summarize. So the lifecycle images are going to live on Docker Hub, right? They're no longer ephemeral, built from the lifecycle built into the builders. And we are only providing then this functionality for builders that state that they have a lifecycle of 0.75 and beyond, right?
Right.
Is that accurate? Okay.
That is correct. And so that begs the question, right? What do we do when someone has a life cycle that is too old? And that's what this Miro board is trying to illustrate. This is sort of like future Pack. If I am building with some builder that happens to, I'll just take us through the sad path for the time being, since that's what we've been discussing. But if I happen to build with a builder that I don't trust, and I'm publishing, so registry credentials are in play here, and my lifecycle image is too old, this is the question we're trying to, or like we're hoping to get input on. We kind of believe that, and the feedback that we got from Emily is that failing is probably what we want to do, because if now that we introduce the concept of trusted builders, it really, like, it seems like something that we want to honor. Users should always be able to rely on the fact that Pack is going to do the safe workflow if the builder is not explicitly trusted. And so
do we have an idea of how quickly we think we can move beyond this particular inflection point? How many sort of builders out there aren't going to be on 0.75 and are unlikely to be upgraded to it?
That would only speak to, I guess I'm assuming, builders that are not trusted, right? So if we look at the things that we suggest, which would be the Google Builder, Heroku, Cloud Foundry, and Pacato, right? Cloud Foundry kind of going away now. Those would all go into the trusted flow.
Yeah,
and so they would be fine, right? So it only impacts custom builders that we're not aware of, that are built with a life cycle that we're not aware of, right? So to answer that question, we don't really know.
Yeah.
I'm assuming the number should be very minimal, but that's an assumption. Sure.
My instinct is the same, and especially since only the ones built before now, not all the ones that would come on the other side of this, you know, based on the last life cycle as we get to 0.75, would also only be affected. So not only do we think it's a small number, it's a number that gets smaller as a percentage over time. And I think I would just do like a call out on Slack to find out if anybody on Slack is likely to do this. But I think fail is probably correct, in agreement with Emily here. It's a bad user experience, but it's a bad user experience that affects such a small group of people that I think it's worth being secure, even in the face of bad UX.
For
the one question.
Oh, go ahead.
Oh, sorry. The one question I have about this graph is the like publish pass node on the flowchart here, because in the daemon case, those builders are still getting access to the Docker socket, and I'm not sure that that is a thing we want to do if we're creating a trusted, untrusted workflow. But I don't know if it's as bad as the registry credentials, right? Because it's usually scoped to a workstation.
Yeah, and that goes beyond the RFC as well, right? I believe the RFC was speaking mostly to, if not only, credentials, not so
Yeah.
much Docker socket access.
Possible the original author of the RFC didn't think through the Docker socket part all the way.
For what it's worth, this maybe on lifecycle 061 is, I just confirmed that that's possible. So that narrows it down even further because someone who's on 061 is going to get to use this happy path.
Especially in that case, I think we're fine because lifecycle 05 is platform API 01, which PEC doesn't even support anymore anyways.
I was looking at the Heroku builder. Do we know which one it uses? I think that's 062. Is that a number?
I think it went to 7.4.5 today.
Oh, nice. Perfect.
But no, we will. I mean, it's important because we've had trouble upgrading, just because there's a lot of clients out there. We have a lot of clients out there that are on older versions of PAC or something else, expecting something in lifecycle, and we've broken people several times, and so we've been extra cautious. I think we're working on some mechanisms that will like auto update the PAC. What's ended up happening is like PAC as a library is embedded in other things. So we're working on some methods to auto update those, and I think we'll move along quicker from now on.
Sounds like you want a non-breaking OX API versions RFC.
Oh, I want to talk about that so bad.
It sounds like we're in alignment to fail. The impact is minimal and I guess more correct in terms of trusting. All right.
Yeah, and I think given a coin toss on UX versus security, we always should land on security here.
That settles it. Thank you.
Agenda, anybody else have anything different? Anything else? Joe, you want to talk about?
I want to talk about the versioning RFC.
Yeah, I was going to say, Emily, are you ready to present that?
Oh, sorry, I was ready to get all angry.
No, perfect. Go for it.
Go for it. Yeah.
I'm so mad. No, I think Emily and I, we were talking about a particular case that she was worried wasn't handled well by the original version of the RFC, which was like, I think the really good example is we remove positional arguments and replace them with environment variables. And I think Emily's comment was that where there, in the original version of the RFC, where there are no modes, essentially, the Buildpack author would have to account for both cases because they don't know like what version of the lifecycle they're going to be running on, right? So they're going to always have to accept positional arguments and potentially create a warning themselves. And then I guess if they don't get the positional arguments, then use the environment variables. But I think in the modes case, like, I think you still have that problem because I think like if you're running on an older version of the lifecycle, even if your compatibility version is 1x whatever, you have to be like, unless you're willing to just as a Buildpack author ditch older versions of the lifecycle, you're still going to have to account for that case. So yeah, I don't know if you want to rebuttal, but I kind of like the first version of the PR first better.
I think my two concerns were, as you described, Buildpack inputs, and then also
Like
deprecations in the spec. Like I don't necessarily want to deprecate things within an API in the spec. I'd rather have the lifecycle handle multiple APIs. I think it's a cleaner distinction. And yes, like once the Buildpack bumps to a new version, if it gets out in front of the lifecycle, it's not going to work with an older lifecycle. But I think you're always going to have an order of upgrade problem, and in some ways it's easier to get the life cycle out in front. The life cycle is the first thing that releases a new API version. And especially with these changes, it'll be easier for the life cycle to be the first thing that implements a new API and for people to pull that in without having to know about that. So I think in some ways this is the easiest path forward because there's only one life cycle, and this should make it easy to upgrade. And then the life cycle can sort of take on that burden instead of spreading it around to 1,000 build packs.
So I don't know. I don't think I agree. Like, let me think through this. So, okay, so first this is a separate concern, but I have it in my head, so let me talk through it. But like having the compatibility version in the build pack this way, like it reminds me of the thing we were just talking about why the Heroku builder was behind on the lifecycle version. And it's that like there have been times where it's like we have to in order to release this new builder, it's like, oh, we have to go update all the build packs, and like literally not changing the code in build packs, just bumping their API version, and it becomes a really frustrating process. And it has definitely slowed down our ability to like ship new things. And
I feel like this is trying to solve that exact problem though, right? Because when a lifecycle implements Buildpack API 03, now none of the O2 build packs need to change at all. They'll work exactly as they did before.
They don't have to, but then they're running against a different version of the lifecycle, right? Like essentially, like they're running a different path through the lifecycle in the binary itself because of that compatibility version, right? Whereas with the previous RFC, they'd still be, it'd just be whatever backwards compatible lifecycle version, potentially with some deprecation warnings. Like I think
I'm not sure I totally follow like why that feels bad. It's always the same, the old build pack running against a newer lifecycle. And then the question is it just being interacted with in the way that it specifies in its Buildpack API, or is it like having to figure out what version of the API is being implemented? Maybe one doesn't even know about, right?
I'm not sure I totally followed. So I do know, okay, so there's two things that we know. One is the minor versions should be backwards compatible, right? Like we agree on that. We agree that 1.0 should be a non-event, right? Like when people upgrade to 1.0, I think the most important thing is that it just works. And it's not like we release 1.0, make a bunch of noise about it, everybody tries to run pack and it breaks because we didn't actually update a bunch of the build packs or something like that, right? I think the problem, like one of the problems with the previous RFC, when we were talking about like removing things in 1.0, or for any major version really, kind of implied that like 1.0 would be an event. So in some sense, that take is at odds with what I think is most important, but I also think we could choose just to not remove anything in this major version.
I think you might be conflating a major event in the spec with a major event in lifecycle implementation, right? I think that the spec 1.0 is actually a big event that has huge numbers of breaking changes, but I don't think a lifecycle implementation has to basically have a big bang right there. We can support both versions of those and allow build packs that only go to 0.3, right? Or 0.4 or 0.7 or whatever it is going to be at the same time as allowing 1.0, so that the effect to users is that it's nothing. The effect to build pack implementers is that they have a runway to make the updates that they need to make. And for the specification, it is internally consistent and breaking as it moves through its life cycle. With lifetime, let's go with lifetime there, not life cycle.
Right. All right. And so in the current proposal, Emily, you're saying that we would accomplish that with the API compatibility version in the build pack, right?
Yes, yeah. We would just
One of
use
the
the API. It's like the same as if, we had a website that had, served up two different versions of the API using the same web server. And then whichever endpoint a client is using, they get the API that they have expected and tested against. In the same way, we're using the Buildpack TOML to figure out what API the Buildpack expects and then just providing it that API.
A thing that's been percolating back in the back of my mind, and it's certainly not on the scope for this RFC or any PRs related to it, but is something interesting to think about. Imagine a scenario where the specification itself never said anything about compatibility, right? It didn't. In fact, it was a single monotonically increasing integer. We had spec 1, and then 2, and then 3, and then 4, and some of those would be breaking and some of them wouldn't be breaking. But the key thing there is that a lifecycle can support 2, 3, 4, 5, 6, allowing this window for people to upgrade as they need to without affecting users of that particular lifecycle, without them having to know exactly which version of the spec version they're on.
I'm not sure if we're ever going to be confident that every version of that spec is going to work with every other version of that spec, though, right? Like, the nice thing about having a major minor is that it does give us an option to say, uh-oh, we need to change something where 1.1 is not compatible with 2.0.
But what you're trying to do is relate versions of the spec and their compatibility with one another, which again gets back to my statement. Actually, the compatibility we guarantee, or that we care about, is the lifecycle implementation compatibility. And you could imagine an implementation which was literally like, you've got a directory that has all of the version 2 implementation in it and Go, and then you just sort of copy paste that, call it version 3, and then make the changes that we need to, and have some sort of switch statement that sits outside of all of these directories that says, here's version 2. If you've tried to come in, you offered me, like your Buildpack TOML says 2, or your Buildpack TOML says 3. We go into a completely different code path. And that's how you guarantee compatibility within a lifecycle implementation, right? That we are going to use the exact same code that always works like this. We're going to make any changes, whether they are breaking or not, in new code going forward.
I mean, what happens when we change something about metadata that's written to the image or something, where like it becomes like the actual interaction between the two build packs running on two different versions, that there's something about it that doesn't fit together?
Right. And so this is fundamentally problematic. And Emily and I have been sort of kicking around the idea that like there is a core, here is the latest thing, and you use effectively migrations to say, okay, you were on 2 and the metadata you kicked out look like this. How do I migrate that to a 3 or a 4 or a 5 kind of thing, and sort of do it transparently to the build packs? But it's not clear to me that build packs on 2 different versions of the build pack specification can actually operate in conjunction with one another. I think this is actually a much bigger risk than we've given it credit for, and specifically is a different risk than lifecycle compatibility up and down. I think it is totally reasonable that we will one day have a lifecycle that supports effectively every single version of the spec we've ever had. But whether you can use 2 different versions of the spec simultaneously is a really, really big question.
That's the only reason I want to keep the major minor. Like, otherwise I agree with you, Ben, that just a number is fine. But I think the major minor we can use to indicate compatibility between build packs.
Or platform side as well. Participants on the platform side, yeah. The key thing here, though, is, and that's why I say, like, I think it's sort of an ad absurdum argument to go to this like single monotonically increasing thing, but it really drives home the idea that compatibility within the spec is not actually the thing we're optimizing towards. We're optimizing towards usage by application builders so that they don't see the discrepancies in the specification or the changes in the specification and the things that they're using to build their images with it.
So
I
that
feel like
means that means if you're on point, let's say your compatibility version is 1.1, and we release something in 1.2 that has a lot of value, but is not necessarily, doesn't require any change to your build pack, like a performance improvement or
a new feature like labels, right?
like what?
Like labels, like image labels, right? Just
Yeah,
a new
right, something
feature
like
that gives you
right?
some new functionality. Yeah.
Well,
And
the labels still interact with output from the build pack, right? If it doesn't require a change to the build pack at all, then it's not really a change to the build pack API so much, right?
Yeah.
It's just a change to the lifecycle that's not part of the API.
Yeah, but let's follow Joe's path down. We're going to make a change to the specification. It is a new feature, but your build pack doesn't have to change to take advantage of it.
Right,
Right.
like there's an environment variable that already exists that you're already using, and it's enriched with some new something, right? Like, I don't know. Maybe there's a case like this, but yeah, just let me confirm what I'm thinking. So if I'm on compatibility level 1.1 and we release that change in 1.2, my build pack cannot take advantage of that in your proposal. My build pack does not get to take advantage of that unless I upgrade my compatibility version. Is that correct?
That's correct.
Okay, so in the previous version of the RFC, my compatibility version of 1.1 would not have mattered as long as I'm not using something that is a deprecated API.
Yes. I do think though, if the API is describing the contract between the lifecycle and the build pack itself, I don't know how a build pack how there can be a feature in a build pack API that doesn't involve
I think,
change, right?
Yeah, I think I really need a concrete example if I'm going to press on that. I mean, the other thing is like, as a build pack author, how do I know when I'm using a deprecated API? I like have to run 1.2 and hope that I've run through every path on my build pack.
Well,
Like
there's
run
no
1.2 mode.
Right. So I think the answer is there's no such thing as a deprecated API, right? There are self-consistent versions. So when you
Yeah,
go, when you're a build pack author.
I meant like a deprecated feature or something like that.
Right. So you as a build pack author are on 1.1, you're like, hey, I need labels, right? I need to go to this other version. Well, you're going to change to the other version, which means that you now have to continue to be compliant with that version of the spec, which has removed some feature, right? Like that means you're done. You don't get to use that feature. In order to gain the advantage of using the new functionality, you also have to come into compliance with everything else implied by that new functionality.
So is this how languages end up with like, in Java, source compatibility versus target compatibility? Is this somewhat similar to that, where we're trying to depict what a build pack is written to interface with versus what it's actually going to do?
Yeah, I actually,
Sure.
Terrence and I were talking about that. I think there is some similarity in that, like, we both, Terrence and I think both like this idea that like, regardless of what lifecycle compatibility version you have, they sort of compile down into the same thing. But I do
like this is totally similar, right? Like you can write and even compile to Java 8 bytecode, right? And you have access to whatever the libraries are, whatever the keywords in the language are at that point, right? The Java Foundation libraries and the Java keywords. And then you can run that in a Java 11 JVM, right? Mm-hmm. Even if, and that's effectively what this is, right? If you're at 1.1, well, the lifecycle supports 1.2 and 1.3 and 2.0 and 2.1, but we're going to make sure, like inside the lifecycle, that the things you expected to be there continue to be there. But if you want Java 11 features, it means you don't get to use com.sun anymore, right? Like you have got to make more than one change. In addition to getting all the advantages of moving up, you have to come into compliance with the things that have been removed on your way there.
Right, but it's not like as an author of that code, I have to change something like in my Maven config to run on Java
Oh,
11.
no, absolutely you do. Imagine your application used ComSun APIs in Java 8.
Oh,
This is
yeah,
going to drop the
No,
Java
that's
there right
different.
here for
That's
people.
different. I absolutely think that like between a Java 8 and Java 11 or a Buildpack 1.3 and 2.0, things will be removed, things will break. I think what I'm saying is like more akin to like in Emily's case, or what Emily's proposing in this, where you have the modes on the minor versions. Like as a Buildpack author, it's different from like an author of some Java code where I'm just writing Java 8 code and it runs on Java 11. I don't really care. I don't have to set anything in my configuration that will allow it to run on Java 11.
No, but the indication is still there, right? Like the bytecode version inside the top of a class file, right? Like once it's been compiled down, it says, I'm class version 52.0. Yeah, that's the discriminator that causes the JVM to do what it wants to do. In our case, it's an environment variable or a key in Buildpack TOML, certainly.
Yeah,
but we have no idea what the internals
really
of a
example.
JVM look like. Right?
Yeah, I actually think this is not a good example because we're talking about a major version here, and I don't think that's the point of contention. I think what's really the thing that, like I was saying, from 1.0 to 2.0, from 1.x to 2.0, we can remove things, break things. We can also just have a separate version of the lifecycle that's embedded in it, like you were saying. Mm-hmm. The thing for me is about the minor versions and how we treat those.
Like, can you as a Buildpack author reasonably expect to be able to use a feature in 1.3 without declaring that you are 1.3? That's your requirement.
That's what I would like. That's what I would like. And it does require rigor on our part to make that possible. But I think it's ultimately a better experience for Buildpack author.
For what reason? Why shouldn't a Buildpack author be responsible for declaring the minimum supported version or the minimum API version for the features that they would like?
It's more about, well, first of all, I think I worry that they will not be, and that they will just leave it at that. Just because it continues to work, they'll just leave it at that old version and never move forward. Just that's what I see people do, right? Like I can really get to update which will Heroku stacks, but
which will only work until they test it, right? Like Emily's policy here is basically like, okay, so I wrote this new thing that uses this new 1.3 feature. I run it inside a pack against the new lifecycle, and guess what? None of it happened, right? I know I need to go update that value as well.
How would you know, other than just like subscribing to the Buildpacks mailing list?
If you knew, so let's use as a compatible thing from 1.2 to 1.3, we add the ability to write a piece of metadata that puts labels on images, right? So I write my build pack, I start using this API, it writes it to the proper metadata file, and I use pack, and the output image doesn't have labels on it, even though I followed this change to the specification. That is the indicator to me that I need to go up, change the API line in my Buildpack TOML from 1.2 to 1.3.
We can add, we wanted to move to actually cutting releases of the spec, right? We can write release notes that say what all the new features that came in a spec release are, and then also do the same thing in a lifecycle release when it implements a new API. Be like, implements platform API 04, and then list out the features.
Right, so what I would prefer as a counterpoint to that is that you don't have, like, regardless of what you specify as your compatibility version, let's say it's 1.1, it will still run on 1.3 with 1.3 code, but with deprecation warnings. And so in that way, you get everything that's in 1.3, but there will be more explicit warnings about that the Buildpack needs to be updated, which I think is a better prompt than needing to actually update.
That's a better prompt than we're just not going to give you this feature. Like this isn't something that like
people won't. They just won't.
Their Buildpack won't go out though. Like that's the whole thing. This isn't actually a burden that's borne by application developers. A Buildpack author will attempt to test this and just won't get the feature. That's their immediate prompt to upgrade, right?
No, the Buildpack author doesn't need the feature, but it is about the users, because if there's something in lifecycle 1.3 that they want, they can't get it unless that Buildpack upgrades its compatibility version.
The Buildpack can't give them that thing anyway.
Well, if it's something like the labels, potentially it can.
The Buildpack then would have to be, then the Buildpack would, performance improvement's not a spec change. It's not a new feature, right? As Emily says, that's a
Are we going to backport? Are we going to backport every performance improvement?
That's a good question.
To, like, there might not be one between 1 and 1.1 and 1.2, and then there might be one between 1.2 and 1.3, and we have to backport it.
Depends how we implement the different API versions in the code. Like, we can do what Ben suggests and have totally different code paths, or we can just, set up rigorous testing to know that we have implemented each API correctly, but share a lot of code that could have performance improvements. Like, there's something that stops us from doing this. Yeah.
Time out for a second, Emily. I think the problem here, Joe, is you're thinking that there will be a performance improvement between API version 1.1 and 1.2. And that's not the case, right? APIs don't have performance in any way. What you are actually talking about is the life cycle between 0.7.4 and 0.7.5 will have a performance implication. And so users, regardless of what their build packs do, can continue evolving life cycle, and the life cycle behavior, performance behavior can change. And that is completely orthogonal to the API version that's currently
I guess
supported.
I would push back against APIs. Not like APIs have implications on performance sometimes too. Like, we were just in discussion about like making some changes to like how something functions for performance, right? Also, I feel like I've missed much of the context of this conversation. So I'm entering in like very missing much of, I guess, Joe's monologue.
I think to Terrence's point, like, most of the time the API doesn't have performance implications, right? It's just the contract.
Yeah,
but like,
I think
there are features like slices that are performance-driven features, but I do think if you want to take advantage of new features, then you need to use the new.
Yeah, right. Like, we're not just going to get, if a user slices, let's use slices as a really good example. It has performance implications, right? And a user absolutely wants to take advantage of it, but it cannot be taken advantage of unless a build pack is updated to take advantage of it. Did we lose Joe? Oh, no, there it is. Okay. Yeah. So that is a performance improvement that cannot be taken advantage of without a build pack specifically making changes to take advantage of it.
Yeah, I mean, I guess my other concern is that, like, how much confidence do we have that these point versions will actually work with each other? Are we putting ourselves in a position where we have no choice but to bump a major version 6 months from now because there's something that we want, but we realize that it can't go in a minor version?
This is something that specs deal with all the time, and I think we will need to be stricter about it. And I think that leads to compromises. And that compromises, maybe we don't get to make the change in the spec, or maybe we don't get to change it to the optimal thing because we balance the need for compatibility over the need for correctness.
That's true in the previous version of this as well, right? Like, you can't have no build packs indicate what API they want and make a breaking change to the contractual build plan and expect to be able to make that work.
You're right. It's still, yeah, it's definitely possible. I think it's less likely because they're ultimately, like, I think just by nature of the way we're talking about the code executing, where, like, there's a thing, it's deprecated, but they're all, you're picking up the new changes as you go, regardless of your compatibility version. It feels less likely to run into that situation, but I agree it's definitely still possible.
Are you basically advocating for taking the Buildpack API out of the Buildpack TOML altogether?
No, because you still need to know. No, you still need your minimum, sort of, right? And then definitely, like, the major still matters.
Yeah, I want,
don't know.
is Joe just advocating for modes to be majors and not minors? Is that like, am I reading
Yeah, that might be true.
that correctly?
That might be true. I definitely am starting to feel like I want different things for the 0x line as I do for the 1.x line. So yeah, that might, I still need to put more thought into it. So that might be the case. I don't know.
I think we
Yeah,
could talk about modes being majors when the 1x line comes out. This RFC like specifically only wanted to talk about the 0x line because I think we know we want to make breaking changes before 1.0. Because I mean, if we want 1.0 to not be a huge, contains every change in the world, but we also don't want it to go out prematurely, there really just isn't another way to do it, right?
The next version after 1.0 is 2.0.
If we make it a 3.0, we'll match the CMB v3. I guess like if you have modes on non-breaking changes, I think Ben was mentioning something of like how if you want this feature and we basically drop support of something else, like you have to do both things.
Yeah, which is admittedly only a major change, right? You'd never, the way the spec is written, that wouldn't happen in a minor.
So I guess what's the benefit of modes in a minor then if you're never dropping features?
Well, I think modes are A, an implementation detail, and B, guaranteed 100% no change. Think like ABI compatibility specifically.
So if every, in theory, change is a forwards compatible change, right? And we're not dropping stuff, are the things that Joe's advocating for this kind of set of minor releases any different from modes?
I am in this RFC advocating for non-purely forwards compatible changes, in particularly the 0x minor line, which is what we already have now. So I'm not introducing that as a new thing we're allowing. We're already allowing breaking changes in the 0x minor line. It's merely proposing how the life cycle will support those in a way that the fact that it's breaking shouldn't matter to platforms or Buildpacks. The fact that the APIs are not strictly forwards compatible.
Yeah, I think what I want actually is us treating every 0x like a major version and then modes for major versions. I think that might actually be what I want.
Isn't that what we have right now?
That is
the point of
exactly what we're
contention.
hamstrung by today.
No, because we're talking about supporting the older modes. That's the difference for the 0x, right?
I think what you just said is actually is another way of describing what's in that RFC, right? Because we said that when 1.0 came out, we would not anymore allow non-forwards compatible changes in the spec. But we are allowing in OX. And this is just using modes to create a smooth experience for people using the OX stuff. And like maybe when we go to 1.0, we could talk about, the mode itself doesn't have to include the minor or something like that.
I need to think about it some more, but I think that might be something, I think that might be exactly what I want.
I probably don't want what you want, Joe.
Yeah, I mean, no, I definitely have not thought it through.
Yeah, I mean, I think about like, we've done a lot of like having to migrate users from stacks and other things on Heroku. I've personally done a lot of white glove service and it's super painful. And there's definitely a thing about like not requiring to do a bunch of work to kind of get a set of features, I think is an important quality to have, even as like a Buildpack author. It's like in the example Ben gave of like getting this feature, but then having to change a bunch of code because all these other things changed. I have there's some yellow flags that raise in my head about that, mostly because it might just mean the build pack authors just won't bother to do the work and won't do it. Like, it's not their full-time job, right? Like, it's a lot of these build packs in the ecosystem that aren't funded by a company are things people are doing on the side.
Yeah.
Yeah, like they
And,
wouldn't
like,
actually
support a thing.
Yeah, like these build pack authors don't identify themselves as build pack authors.
Sure.
They are
Sure.
like Elixir maintainers, you know.
Yeah.
They happen to write a book.
And that's the argument to never break, like basically to never have a major beyond one, right? To never break backwards compatibility. The problem I think that your suggestion, Joe, leaves us with is if you want modes for everything pre-1, it means 02s can't run with 03s, and 03s can't run with 04s, and 04s can't run with 05s. And that's problematic because it forces build pack authors to upgrade versus saying, we consider these things to be compatible, even if the spec isn't strictly. We're going to put the burden on the life cycle to make it as if they were compatible with one another. And then once we get to 1, 1, 2, 1, 3, 1, 4 actually has to be compatible, reducing the burden on the life cycle at that point. And if we ever have to break and we have to go to 2.0, like, we better really mean it, because most build packs won't come with us.
My proposal mostly wants to treat 0x's as majors that are bridged with modes, with the one exception that we're guaranteeing they can run in a group together. Because I think if we don't guarantee that, it's too much to ask from people.
Wait, what's that guarantee? What?
That they can run in a group together. That's the only thing that is different in my mind about the 0x's from like different major modes, is that I want them to be able to run in a group together, because I think otherwise it's going to be really painful.
Concur with that.
Yeah, I guess ideally I would like just an evolving API that is just forwards compatible.
Broadly compatible forever. Right. I totally agree. We have not been great about making the hard choices so far to ensure something like that happens. So we will, like, something drastic will have to change if we want to achieve that as a goal.
I guess some of my concerns around modes and other things with kind of the spec versions without those design goals in mind, even if we have them in the back of our head, is that if you remove stuff from a spec, like, you don't remember that that's a thing someone's using. Because if you're always just looking at master, like, it's kind of like out of sight, out of mind. I think I made a comment on the RFC pre the rework that is now not applicable, but like say like 0.2 to 0.3 is a new mode, right? Like, and there was some API feature or thing that we decide to remove or change, like, now it's just part of a mode that you kind of now need to know the context. And say we get to 0.7, right? Like, are you going to remember, like, say we support all these modes in lifecycle because it does it, like, are we going to remember like what people are doing in 0.2? Does it matter when we involve the spec to know that we have a large number potentially of users that are doing that? Whereas if you had a kind of more unified API look, like, if you deprecate features in the spec, like, it's there. It's kind of like the RFC thing, right? Like, it's there in your face and you know, like, that is a thing, and like you have to deal with it to some degree.
I guess when you say will we remember, like, who and in what context?
Well, I mean, we as the core team that has to merge stuff in when stuff comes in through the spec or changes, right?
Like, all the versions of the previous API documents will be available.
Sure, they exist, but like, are you going to go back and look at
testing
that
and
version?
making sure that all the APIs work, right?
No, it's not even look at that version. You have to go back and look at every version.
Yeah, like I guess like I know, like, I'm probably not going to go look at 0.2 of the spec when I'm working on 0.11 of the spec, right? Like, because that's what happens to be what master is, or the latest version we're working on, right?
Why
to me,
is this
as a lifecycle implementer, that is like a easier problem to solve than like every combination of deprecated and undeprecated features sort of existing together at the same time, regardless of what version is in the Buildpack API version.
Yeah, why isn't that just a bug like every other bug? Like, obviously, we don't want to do that. We would endeavor to create enough testing and enough framework around it to be sure that we didn't. And if we did accidentally, we'd fix the bug and cut another release of the lifecycle to reinstate anything that we accidentally removed. Like, it's not a purposeful thing that we're going to go and remove some sort of piece of functionality. It's an accidental thing that functionality gets dropped.
I think Terrence is saying we're setting ourselves up for that being more likely to happen with the not having the deprecations in the spec. I mean, I get like the reference example that I was using was the JDK specs where the deprecated methods are there forever and ever and ever. Hate on that as much as you will. It did pretty well for Java through lots of things.
Right, because the deprecations didn't actually matter. The API stayed forever, as you say. We would have had the exact same outcome if no one had ever marked any of those deprecated. The key takeaway, I think, there is actually that they never broke compatibility, ever. They acted like they would one day, but they didn't, and no one ever stopped using the APIs.
The example that I think of that I want us to be more like is sort of like migration from Docker V1 to V2. So they realized they needed to overhaul the file description of an image, right? So they made a brand new specification. And the Docker V2 spec does not contain within it the entire Docker V1 spec, but deprecated. It is different. But then Docker, the command tool, can run either of those types of images for a long stretch of time without you having to think about that.
I have to think through this. I feel like this is actually an example that makes me not want to do it that way. And I'm thinking of Docker Compose specifically, and the things that I had to do that were not major versions. Now, I don't know exactly how they treated it, but all right, I have to bounce. But yeah, we should definitely keep talking. Maybe set up this a special session for this because I think it's really important. Bye.
Sounds great. Okay, thanks everybody.